Welcome. This is the first part of a video series to diagnose and repair an LG refrigerator. We're going to focus on the LG bottom freezer refrigerator that is not cooling at all. Our first step was to determine if the printed circuit board is sending voltage to the compressor. We actually went a step further than what LG recommends, as we were curious on the linear compressor waveforms during startup. The printed circuit board has been flashed with version 8.9 firmware. We used the flowchart shown to go into test 1 mode, which is the best way to induce startup voltages to the compressor. We hooked up our digital voltmeter to common and power after disconnecting the connector 201, which leads to the compressor. We set the meter for AC volts while measuring frequency as well. So after 30 seconds, you can see we exceeded the 200 volt threshold. We actually were 213 volts. We even observed a little bit higher. So this told us that we were putting sufficient voltage out to the compressor. We have the Rigol hooked up to LG refrigerator. We are running in test mode 1, and we are just 20 seconds into the startup. Okay, go ahead, Curtis.
Notice how short the pulse width, how
Yep.
narrow that is.
Yep.
Now as the test mode runs on, that'll start getting wider and wider.
Okay.
And that's what we're looking for a good board.
Okay, so let's see what
See,
happens.
it's starting to widen out already.
Yep. So we'll wait for that 3-minute mark, right?
Yeah. And that just keeps, each one of those widths represents a different motor speed.
And it does show us the voltage currently is 300.
So
The
it's
yellow down there?
It's a pulse width modulated variable drive.
Okay.
See how they're getting wide now?
Uh-huh.
They're almost at 50%. When it reaches that first line, it'll be 50%.
Does this tell us the voltage is down to bottom quarter here?
No, because I have that sine wave transposed and I have the
Okay.
time base cranked out so that we can see the pulse widths.
And you've got this
Before,
set up.
this was just looking like noise.
You've got this set up so your two inputs, channel 1 is
a reference.
one of the leads.
Yes.
I'm going to just go over here. So we're alligator clipped on right here. So channel 1 and channel 2 is feeding off from that jack. And that's
Yep,
what we're
I'm
feeding right
using
into the
channel 2 as a
oscilloscope.
reference.
Got it. So we're 2 minutes into this.
Now I can do some different stuff. I can put some cursors
No,
on
that's
this
all right.
bit.
We're gonna.
Now you can see that we're more than 50% duty cycle.
Yep.
So this will just keep getting wider and wider. And it, like I say, each one of those widths
Okay.
represents
So
a different
I'm
motor
going to
speed.
stop this video now, and what we're going to do is change the board out. And we're going to see if we get the same waveform with the
Okay.
other board, okay? Is that fair?
Yeah.
Okay, so here we go. All right, test number 2, different board. We just started our test mode 1 on the board. We want to see if this thing has the same type of output as the other board,
We have very narrow pulses.
which it was before. As the fan has started, it looks the same, doesn't it?
Yep, the pulses are starting to get wider.
So these are two printed circuit boards that we're comparing. The original one for this refrigerator with the 8.9, I think it was 8.9 level version software,
Yep.
and both of them have the same version of flash.
And we're starting to get close to 50% duty cycle now.
And we're sitting at 1 minute. can't really tell what the settings are of anything here, can you?
No, because it's a digital scope.
Right. So it looks to me that both boards are good. They're both putting out like a DC.
Well, it's a variable duty cycle DC pulses.
DC pulses, yep.
See, now the pulses are getting really quite wide.
Yep. And it looks like the height of from doing the previous to the new, it's the same.
Yeah.
So it's the same voltages.
Yep.
Same level of power, right?
Yep.
Now, if we would have reversed the leads on A and B, this probably would have been up above, just showing. So we're just picking up a reference.
Yeah. So yes, because it's DC across the motor.
So we're 2 minutes and 30 seconds into this test, and it's looking good. I think we go ahead and shut this off, right?
Yeah.
We concluded that the original PCB board is okay. Our next video, we will focus on the compressor. Thanks for watching, and please subscribe.